Looking for complementary. Don't have, I think there's only one. Just the definition of complementary angles. If you're not sure what it concludes, you might go look, but I think at this point, a lot of you probably are okay, using the law of detachment where if it satisfies the conditions, make the conclusion. So when the conditions are there complementary, the conclusion is, we'll go ahead and make that then. What it says you can do, you can say that the sum of the measures equal 90 degrees. Well, 2 and 3 are also complementary, so use the law of attachment, make that conclusion. That, it satisfies those conditions, make the conclusion. That's the law of attachment. So we are using definition of complementary angles to make the conclusion of its statement, then equal 90. Any ideas? That's all we have. We don't have a picture or anything. We've got to be able to do something with that and somehow show that 1 would have to be the same as 2. Maybe try replacing something. So can you replace the 1? Well, there's not, then that measure of angle 1 equals 2 anywhere else. Can you replace the 3? Well, there is another 3, but it's not equal to anything. And technically, we could do that. If we wanted to solve for measure of angle 3, we could substitute. But keep going. 90 is already solved in both equations. It equals 2 separate things. So I think that's what we're going to replace. And you can pick either equation. Let's just start with the first one and see what happens. If I say measure of angle 1 plus measure of angle 3 equals 90 degrees, but replace something. I can't replace the 1. You could replace the 3, but it'd take a little work. If we replace the 90, so if you want to just erase that and replace it with, well, what else equals 90? Measure of angle 2 plus measure of angle 3. Replacement rule. So now we have a relationship with 1 and 2, which is what we're trying to prove. The relationship between 1 and 2 is they should end up being the same. Right now, I've got more than that going on. But if this is going to work out, we should be able to take this new relationship and get from here to 1 being equal to 2. Which, what do you notice? Do you see that measure of angle 3 is on each side? We've done this a couple times before. You don't have to show subtracting the measure of angle 3, but I'll write it down just to help you follow it better. We just need to show that if we did subtract 3, we would get measure of angle 1 equals measure of angle 2. If you're not sure what property, maybe pause the video, go search for your property. You're looking for the property that says you can add or subtract something from both sides of an equation. Additive property of equality, APE. And we're right there. We don't even have to switch the order using symmetric property. All we have to do is change to congruence, which, and we've talked about what it means to be congruent. It means all the measures are the same. So to prove something congruent, you need to show all the measures are the same. And with an angle, you only have one measure. So if you've shown that one measure the same, that's all the measures. And you can, by definition of what it means to be congruent, we'll say definition of congruent angles, you can state angle 1 congruent to angle 2.